So in order to solve an equation like this, we subtract the 5, which undoes it. We get x equals 5 because subtraction is the opposite of addition. How about if I have something like, I don't know, x over 4 equals because it's the operational inverse. It's the inverse operation. Like up here, add or subtract. Those are inverses. Oh, I'm sorry, I was off the screen. Down here, we've got multiply or divide. Those are opposite operations. They're inverse operations. They undo each other. I never solved this one. This was x equals 48. Okay, next. What would we do to undo a squared? We do a square root. Because powers and roots are inverse operations. So when I do square root both sides here, what do I get? I get plus or minus 5. Does anybody remember that rule from the past, from the previous courses? If you're going to square root both sides, you've got to have either a positive or a negative, because if I were going to go backwards, negative 5 squared would be positive 25. So you're not sure which one it would be. It could be either. All right, should I do a hard one now? You're like, this stuff's too easy, isn't it? Hard one? It's supposed to be a 10. It's a really ugly 10. This is exponential. What's the inverse operation of exponential? Yeah, logarithmic. I don't know how to spell it. I think that's how I spell it. Logarithmic? L-O-G? Did those last year? Please don't tell me no. I know you did. We're not doing those yet. I just wanted to bring that up because those are inverse operations as well. So today we're doing inverses, but we're doing them with graphs because we can also have inverse graphs. We can have inverse functions. We can have inverse equations. So here, my first example, actually there's stuff before that. I'll talk paragraph after we graph. This first example, the function f of x equals x plus 4. Let me graph that one real fast. F of x equals x plus 4. Where am I going to begin? At 4 on the y-axis. So 0, 4. We're going to begin here, and then where are we going to move from there? Up 1 over 1, we'll use our slope. That's good. I got some points. Got my straight edge. There's straight edges all over my room. If you want to make a straight line quickly. Okay, and then this here says the inverse of this function is g of x, which is x minus 4. Or it is f to the negative 1, which means inverse function of x. So these are two different ways where you might see it written, and it just depends on what book we're using or what teacher you have next year. I just want to show you, like, both of these could be used for the inverse. So my inverse, x minus 4, so I'm going to begin at negative 4, and I have a slope of up 1 over 1. What inverse functions have in common every single time is A, are symmetric in this y equals x line. They're symmetric in the y line. So if I were going to fold my paper at the y equals x line, these would match up every single time. So as we're graphing these and finding equations, you will be able to tell visually if you're doing it right, because these should be mirrors of each other in this y equals x line. So inverse functions have opposite operations to them. So here I've got examples. I've got f of x equals 2x plus 3 and g of x equals x minus 3 over 2. If we think about what's being done to the x here, if I know an x value, I first multiply by 2, then I add 3. In the inverse, I first subtract 3, then I divide 2. Do you see how we have opposite operations in the opposite order? That's something that inverses have in common. They have opposite operations in the opposite order. If one has a plus 3, the other one's going to have a minus 3. If one has a times by 2, the other one's going to have a divide by 2. And they're in the opposite order. Here, these are already graphed, so we don't have to take time to graph it. We just look at it. Here are the original function, 2x plus 3, and the inverse function, x minus 3 over 2, are graphed. And they've named one of them f and one of them g, so you can find the two equations. You can see symmetric in the x line. Something else, though, that you should notice is look at their ordered pairs. Look at the table, and look at the table below. What do you notice about these two tables? Yeah, they're interchanged. They're switched. Yeah, they're totally. So y equals x line is saying that when we have inverses, all of the y's and the x's switch. All the y's equal x's and all the x equals y's. That's what's happening. Which is making them symmetric here in the y equals x line. So if all I knew about the graph was inverse, I could just switch the ordered pairs and I would have the inverse. Okay. So finding the inverse of elation. So you should have done this last year. This should be, review. We're just going to add on a teeny bit harder stuff this year. Just harder stuff. So finding x equals 3x minus 1. We're going to find the inverse and graph it. Let's just start by the algebra first. First thing that I'm going to do is y equals 3x minus 1. That's my first step. Then I'm going to find the inverse. Here we go. I'm going to do it. I'm about to find the inverse. Are you guys ready for this? Are you ready? Okay. If I switch x and y, I have the inverse. If I switch x and y, I have the inverse. So here we go. Done. I did it. I have the inverse equation. How many people think I can do that? Nobody? How many people think you can do that? Come on! I'm trying to make it a little bit exciting here. It's not that exciting. You switch the x and y and you're done. Well, except we need to graph it. So we don't leave it like x equals. We never leave the equations x equals. We just change them around and now solve for y. So that is the inverse equation, but I am going to solve that for y. So what am I going to do to both sides to solve that for y? Add 1. So I have x plus 1 equals 3y. Divide by 3. So I have y equals x divided by 3. That's all for y. So that's the inverse equation. If you're going to go graph that, maybe you would possibly want it like 1x plus 1/3. Maybe. There is one more step, though, that I'm about at you, but there is one more step. We're going to write it back in function form. Write it in function form if it is a function. Why can't I write today? We're going to write it in function form if it is a function. So that maybe we need the graph for, maybe you would just figure out what makes it a function as we're doing this today. I'll go over it, but let me graph my original one here. 3x minus 1. Okay, so this is the F equation. How can I graph my inverse? There are two answers that I could think of right now. How can I graph my inverse? Prob? What do you mean by opposite? Take the ordered pairs of this graph and do what with them? Switch to x and y, and then graph those. Because as long as I've graphed this correct, then if I switch the ordered pairs, that will be my inverse. That's one way I could do it. So instead of 1, 2, I'm going to graph 2, 1. Instead of 2, 5, I'm going to graph 5, 2. Instead of 0, negative 1, I'm going to graph negative 1, 0. Instead of negative 1, negative 4, I'm going to graph negative 4, negative 1. And as I'm graphing these, I'm just going to think to myself, is this looking symmetric in the y equals x line? If I were going to fold on that y equals x line, would these mirror over that? Just make sure. If you switch the ordered pairs, they should. So this is the correct graph. No matter how bad I did my algebra, this is the correct graph. Another way of graphing would be to use our slope and our y-intercept. So we begin at 1/3 and then go up 1 over 3, up 1 over 3. It's just not going to be a very pretty graph to try to figure out. So now I go back and I ask you, is the orange one a function? Does vertical line test? If I take a vertical line, does the vertical line ever hit more than once at any part on this function? No. So is this a function? If it is a function, you write it in function notation. You could either write the function inverse symbol, and that would be like 1/3 x plus 1/3, or you could write g of x. It's up to you which one you choose to write. You can also write x plus 1 over 3. That one is okay to write as well. Over here. It doesn't have to be all fractions. So that would be your final answer in your graph. Okay, if you have a line and you reflect a line in the y equals x line, will it always be a function? A line. Yeah, in order to not have a function, we would have to have some sort of curve that line more than once. So it's not all lines when you inverse them. So if we have inverses of nonlinear functions, here I have my original function is the f of x right here. And that is a parabola. That is quadratic. F of x equals x squared. But when I flip that x line, when I inverse that equation, is it a function anymore? Is that a function anymore? It's not a function. It still is an inverse. You just can't write it in function notation. So when we reflect these, when we switch x and y and we get x equals y squared, here you would just solve for y and you would get plus minus square root of x as your inverse equation for this one here. You would not write it as f of x. Okay, I'm going to pause this video because I have to get up and show you something with my arms. And so example 2 of x equals x plus 4 squared, comma, x is greater than or equal to negative 4. This has a domain restriction. Like when we did piecewise functions, the domain restriction. So if I'm going to graph this, let's just graph this. And we're going to think about transformations because that's what your quiz is on tomorrow. What do we know about this one? The parent function is quadratic. So we've got our U shape. And then what's happening to the parent function? Left 4. So I'm going to take that parent function. I'm going to go left. 1, 2, 3, 4. And I'm just doing this really lightly because of this domain restriction. I'm going to get rid of some of these points. Okay? It's like so light you can barely even see it. But this is just the quadratic transformed to the left 4. But what does this domain restriction tell me? I'm only allowed to use x's that are greater than or equal to negative 4. So I'm allowed to start at negative 4 and use the right side. So I cannot use the left side at all. Let's go ahead and draw in our y equals x line, and let's find our inverse picture, and then we'll go do the math in a moment. So if we're going to inverse this, we just have to look at ordered pairs. Negative 4, 0. The next ordered pair, or the inverse ordered pair would be 0, negative 4. Or negative 3, 1 is going to be 1, negative. Negative 2, 4 is going to be 4, negative 2. And negative 1, 9 will be 9, negative 1. And just looking at the shape of this graph, could you tell me something about that equation? It's going to be a square root. And if you look at the equation that's squared, we know the inverse of squared is square root. So we're giving ourselves some hints here. Let's work it out. What's my first step if I'm finding the inverse? Just switch x and y, but I don't see y. I don't see a y. So I'm going to start out by saying f of x is actually y. You can't do anything with the domain restriction when you're finding the inverse. We're just not going to forget about it. So now I'm going to switch x and y, and I'm going to have my inverse. And I have to solve this for y. What do I do first to solve it for y? Square root. If I square root, there is going to be two answers. If I square root, what also do I have to do? Plus minus. If I square root, I'm going to have to plus minus that. So now I have plus minus square root x equals y plus 4. So now the inverse operation of plus 4, which is minus 4. I'm actually going to put it in front of the plus minus because that's typically where we would put it. Now, this is not the full answer because this is saying we're going to subtract 4 and we're going to do the positive and the minus of this square root. That's what this is saying by transformations. This says we're going to subtract 4 and do positive and negative version. but you're looking at the graph. Is there a top and a bottom? No. What do I need to get rid of? I need to get rid of that negative because that's not part of my inverse. And that's where the restriction came in. Because we had a restriction on the original one, that puts a restriction on our answer. Say, if it is a function, we will write it in function notation. If it is not a function, you just write y equals. So I got rid of the subtraction part. It's only the positive version. It's only the one that goes up of the square root. So we are using transformations now to do something else. So, thinking about transformations, a normal square root looks like this. If I do a reflection on it, it would look like this. And to do a negative in front of the square root.
So then how do you know like which one you want? Like,
because I graphed it first. Yeah, because I graphed it first. I'm sure that we can figure it out algebraically, but you're going to have to graph them for me anyway. Let's just use our graph. The graph I know is going to be right. As long as I graph the original correct, I know I have my new graph correct because I just switched the ordered pairs, and that's the easiest way to graph them. I'm going to skip just example 6, and that'll be the last one we do today. And then I'll give you time to like ask questions about your quiz or just graph some of these and see if you understand it. Did I say 6 or 5? Okay, we're going to do 5. Whatever one I said, we're doing number 5. So we're going to consider this function, and we're going to determine whether the inverse is a function, and we're also going to find the inverse. So we're going to find the inverse first. To find the inverse, you're going to make f of x y. And then we're going to switch x and y. So here's my inverse. I'm about to do it. I'm about to inverse it. Here we go. Switch x and y. X equals 2 square root y minus 3. Done. Found the inverse. But now we are going to solve for y. So we have to use inverse operations to get y by itself. What should we do first? This says 2 times. What should we do? Divide by 2. So we have x divided by 2 equals square root y minus 3. What's the next thing I need to get rid of? Square root. So what undoes square root? What's the inverse operation of square root? Squaring. So we're now going to square both sides. So I have x squared over 4 equals y minus 3. Now what do I do? Add 3. I'm just reversing the order as I do this. Y equals x squared over 4 plus 3. So this is hopefully the inverse. If you guys have your graphing calculator, I didn't put a place to graph it on here. Let's go ahead and graph our original function and our new function. This is also a good time to see whose graphing calculators are set up correctly so I can troubleshoot. We haven't really used our graphing calculators yet. What? We're allowed to do this? Just for a moment. If I put a graph here, we'd just graph them by hand, but I didn't. So I typed in 2 square root x minus 3, and I'm going to arrow down, and I'm going to type in x squared over 4 plus 3. Do you guys know how to put fractions in your calculator? Okay, so some of you are going to have to use parentheses, but if you have a newer calculator, there's a shortcut. So let me show you this shortcut. If you didn't have me last year, maybe you don't know it. But not everybody will have the shortcut. So if you go alpha, y equals, and a menu pops up. if you go alpha y equals and a menu pops up, you have software that's updated, and if you hit enter, it gives you a nice little fraction thing. If you hit alpha y equals and nothing happens, you do not have the updated software, and you'll have to type your fraction in with parentheses. I can type in y3. I can type in the way with parentheses. So if you can see it either way. Let's zoom in more a little bit. Okay. Third over 4 plus 3. So if you don't have the alpha y equals capability of doing the fraction, you'll have to do parenthesis x squared divided by 4, close parenthesis, plus 3. If you don't use the closed parenthesis, you'll probably get it wrong. Okay. So you don't have to type in all 3. You type in 1, and then you either type in 2 or 3, just depending on which calculator you have. Do you understand what I'm saying? Then hit graph, and I have any issues that I need to fix real fast, and let's see if we are correct. Let's see if we have the right answer. Oh, we should also type in y equals x. Sorry. Go make another equation, y equals x. Type in y equals x also, so we can see that reflection line, because the calculators are rectangular. We can change the window to make them not look rectangular, but they're rectangular. So, anybody have any issues? Anybody have any issues? I can't really see. Hit zoom. Stick. I'll fix your window. You have any issues? Troubleshooting here? Oh yeah, you have to use my you have to figure out yours. You used it last year. You should be somewhat good. You have to use parentheses on yours, right? Did you have to use parentheses, or were you able to use the alpha equals? Did you have to use parentheses on yours? You did? Did you have to use parentheses on yours?
No, but I did.
Oh, okay. Okay. Did we have the correct answer? No. Are these mirrors of each other? Part of them is. These are not complete mirrors of each other. What's happening? What's going? Then my red one's my second one. What's wrong with my red one? What'd you say, Amelia? I think that's because it's not a square. I think you can do zoom 5 and make it look more square. That's not what's wrong with it. Yeah, whoever said that, who is that? Katie? Oh, I'm fixing it to see if it looks more square now. It's taken a long time to graph though. So I made it look a little bit more square. Neem, what were we going to say? Go ahead. I know she said it, but go ahead and reiterate what she said. Say it again. Well, what were you going to say?
Like it has the X star both.
The red one has both sides. The blue one doesn't. So what happened is when we went from a square root to a squared, we added in a part that wasn't there. So what you have to do is you have to take away a part from your answer. Is this a function, by the way, the red one, before I go on? Is this going to be a y equals, or is it a function and I can write g of x? Okay, so I will write g of x because of that. But am I going to take away the positive version or the negative version? Actually, let me ask that question. Which one should I keep? Positive or the negative? The positive. So what I'm going to add on to my answer, I'm going to put g of x equals x squared over 4 plus 3. I'm going to put a comma, and I'm going to say my x values can only be the ones that are greater or equal to 0. That will give me the positive part of the red stuff, greater than or equal to 0. Not that part. It still doesn't look perfect, but it's just because it's on the calculator. Okay? That's probably the hardest part of this whole thing, is figuring that out. So I'm going to stop talking now. I'm going to give you an assignment. Probably won't even get Oh no, we're not. You do not have to have it done tomorrow, but you will have it to work on after your quiz tomorrow. You can work on some of it because it is quizzes over graphing. Ask me questions about what's going to be on your quiz, which you guys have how many? One review? I gave you one review, right? And the answer's online. So if you have any questions, now to the end of class is a good time to ask. If not, then you'll work on this worksheet.